let us consider Thevenins theorem. So Thevenins theorem states that any circuit having a number of voltage sources, resistances and open output terminals can be replaced by a simple equivalent circuit consisting of a single voltage source in series with a resistance, where the value of voltage source is equal to open circuit voltage across the output terminals and resistance is equal to resistance seen into the network across the output terminals. So, in order to understand it clear, consider a simple circuit. So, this consists of 3 resistances and a voltage source and a load resistance RL, and here it is R3, R1, R2, voltage is V. So indicate AB across the load resistance and the current through load resistance is indicated in RL. So this is the given circuit. It has to be converted into Thevenin's equivalent circuit, which consists of V Thevenin in series with R Thevenin, and the load resistance connected back, it is equals to RL. So you can find the current IL. So IL will be equal to V Thevenin by R Thevenin plus RL. So this is the Thevenin's equivalent circuit. So this theorem states that the circuit having a number of voltage sources, resistances and open output terminals is replaced with a single equivalent circuit consisting of a single voltage source in series with a resistance. So this voltage is obtained, which is nothing but equal to the open circuit voltage across the output terminals, and this resistance R Thevenin is equal to the resistance which is seen into the network at the output terminals. So in order to calculate the open circuit voltage, that is nothing but equal to V Thevenin, we have to first remove RL. Right. Then the circuit can be rewritten as R1, R3, R2, and this is the voltage V. Here the load resistance has been removed. So V Thevenin has to be found. We know that from the voltage division rule, if you want to calculate the voltage across the mth resistance, it is equal to Rm by R total into Vs. So as this is open circuited, the current passing through R3 is 0. Right. So V Thevenin is directly applied across the R2 resistance. So V Thevenin is equals to R2 by R1 plus R2, the total resistance, because here it is infinite. So the remaining resistance is R1 plus R2 into the voltage is V. So V Thevenin is being obtained. Then second step is to calculate R Thevenin. Voltage source is to be short circuited and we have to calculate the resistance between the terminals AB. So circuit is redrawn as R1, R3 and then R2. This voltage source is being shorted up. So we have to calculate R Thevenin across this, looking into the circuit. So R Thevenin is equals to, here if you observe that R1 and R2 are connected in parallel. So 1 by R will be equal to 1 by R1 plus 1 by R2. So finally it is R2 plus R1 by R1 R2, that is 1 by R. So R will be equal to R1 R2 by R1 plus R2. So finally the R Thevenin will be equal to, the circuit can be redrawn as, this is R3 and here it is R, which we have calculated now, and AB. So R Thevenin is equals to R3 plus R. So it is R3 plus R1 R2 by R1 plus R2. So R Thevenin is obtained. So once R Thevenin, V Thevenin is being obtained, Thevenin's equivalent circuit will be drawn and the current passing through the load resistance can be obtained. So let us consider a simple example in order to understand the Thevenin's theorem. So consider 10 ohms, this is 4 ohms, and here it is 5 ohms. Voltage is 15 volts and here the voltage is 9 volts. So we have to calculate the current flowing through 5 ohms using Thevenin's theorem. So this has to be converted into V Thevenin in series with R Thevenin, and then the voltage across the terminals should be, the load resistance here RL is 5 ohms because we have to calculate the response in 5 ohms, right. Then first step is we have to calculate the open circuit voltage, that is the V Thevenin, right. So what we have to do, remove RL, that is 5 ohms. So redraw the circuit. This is 10 ohms. Here it is 4 ohms. Removing the 5 ohms. Here it is 15 volts and here it is 9 volts, and this is V Thevenin across the terminals A and B, right. So now apply KVL, Kirchhoff's voltage law. So assume that the current flowing through the circuit is I, then applying the KVL. So when current starts flowing in the circuit, minus to plus, it is a rise. So 15 minus, drop in the resistance is 10I minus 4I. So current is flowing in this direction, plus 2 minus, it is a drop. So minus 9 is equals to 0. So 10I plus 4I, it is 14I. 15 minus 9, it is 6. So minus 14I plus 6 is equals to 0, from which you can calculate the current as 6 by 14. If 6 is taken to other side, minus 14I is equals to minus 6. So minus minus gets cancelled. I is equals to 6 by 14, which is equal to 0.428 amperes. Right. Then if you see into the circuit, I current is obtained. So substituting in the equation to get the V Thevenin, so consider this simple law. 15 is the rise minus 10 into the current obtained is 0.428 and the voltage across the terminals is V Thevenin minus V Thevenin is equals to 0. So this can be easily understood by considering 10 ohms, because our aim is to calculate the voltage across the open circuit terminals. So this is Thevenin plus 2 minus, right. So current is flowing in this direction. So minus to plus, it is a rise 15, and drop across the 10 ohms is minus 10 into I. Already I we have calculated here. So 15 minus 10I, and plus 2 minus, tracing the circuit, it is drop. So Thevenin is equals to 0. So substituting it, 15 minus 10 into 0.428 minus Thevenin is equals to 0. We can obtain Thevenin, which is 15 minus 4.28, that is 10.72 volts. Now to calculate R Thevenin, second step is to calculate R Thevenin. So in order to calculate the R Thevenin, the voltage sources, if they are present in the circuit, it has to be shorted up. So 10 ohms, 4 ohms, and here it is open circuited. So this 15 volts is shorted, and here 9 volts is being shorted. So here we are having 10 ohms, and here we are having 4 ohms. So this can be redrawn as 10 ohms, 4 ohms. If you take the terminals outside, so you can observe that 10 and 4 are connected in parallel. So equivalent resistance is 10 into 4 by 10 plus 4, which is equals to 2.857 ohms. So finally R Thevenin is obtained, Thevenin is obtained. So you can find the Thevenin's equivalent. 10.72 is your Thevenin voltage, and R Thevenin is 2.857 ohms. So this is R Thevenin, and here it is Thevenin. So we have removed 5 ohms resistance. So 5 ohms is connected back, and we have to calculate the IL, which is flowing through 5 ohms. So IL will be equal to 10.72 by 5 plus 2.857. So finally it is 1.36 amperes. So this is how we have to calculate the Thevenin's equivalent circuit parameters. Thank you.